Hey guys, it's Jerry Stone. I'm not gonna dedicate much to this video to tell you why I've been gone. I'm sure many of my other videos can help fill you in about that if you're curious. But today, we're gonna work on this little Emerson All-American 5 radio that I got from a recent radio estate sale. It's a little bit different from what I have in my collection. It has this like light wood cabinet and this like back painted translucent front plate. It's really nice, although hopefully it won't be too difficult to fix because it's just a standard All-American 5 circuit model. This looks like it's a 578A, and looking inside it looks like it has miniature tubes, which are my favorite. So this time we got some extra equipment. Variac battery power supply, we won't need that, but Variac will be useful along with our isolation transformer, so let's get started. Alright, we're going to get the cord here. And pull that out. Might leave the cord intact. This has been replaced, although it is a tad bit stiff, so we'll get our cord here, plug it into our isolation transformer in Variac, and we're at 0 volts, so we're going to turn the radio on and turn the transformer on. We're going to bring it up to about 60 volts, and see, I do not, it's 2 filaments, some of them are starting to glow. Looks like 1 tube, so we're going to bring it up to 90 volts. That should at least start all the filaments going. And everyone's starting to glow. You got this. This is just a nice radio. I like the painting. Kind of reminds me of the DeWalt. It has some of those elements of that, but without the whole cabinet being, big plastic cabinet. Oh. Got a bit. Let's turn this up to 110 volts. That's 100, 110. This is full voltage.
¿Y cómo se han sentido? Oiga, ¿cómo han sido los bien bendecidas y sabidas?
What? How important is that?
And just right. Well, let's start taking this apart, and we'll pop the front 2 knobs off. Got this nice, like, I don't know, swirled pattern. It's probably plastic, not Bakelite. We're gonna turn this around. Usually you don't need to remove these screws. We're gonna get out our towel here. Always a good idea to both protect your table and your radio. And underneath, indeed, we have 2 socketed screws. Yep, socketed screws. So I'm actually gonna put this on a screwdriver here, and this is a 1/4 bit. So, yep, with the DeWalt you had to be careful because there was a knob on the side, but usually taking apart radios, especially this one, extremely straightforward. All-American 5s, unless if they're really late, because then manufacturers liked, gluing things into the cabinet and not using screws and all sorts of weird stuff. Okay, first look inside. Well, I've looked inside this before. Let's not get ahead of ourselves here, but first look for you guys. It's a nice chassis, All-American 5, got 5 miniature tubes. And underneath, all original from what it looks like. This works great for being all original. I mean, you can even see the filter cap is being squeezed, and it still looks really great. So yeah, let's get a close up on that. Got the tubes are still warm. Got this little protective part over the speaker. Hopefully that'll be helpful in making sure that I don't poke it. But inside we got our main electrolytic hardwired in. Then we have 1, 2, 3, 4, 5 wax capacitors. So this should be pretty straightforward. But in this video, I'm going to walk you through a bit more of the soldering side of things, because usually I kind of skip past that, even though in some of my old videos I tried to make an attempt, but this time we're really gonna try to be pretty thorough. So let's get started on soldering. All right, I'm gonna skip past some soldering basics, but to get started on a radio, here are a couple things I recommend. So you can either get a soldering iron or a soldering gun. I have a soldering gun, but if you look at some of the older videos on my channel, I use this soldering iron. Anything that's not like super low powered for like little PC boards, hobbyist electronics, should work. Something that actually plugs into like a base station, so a bit more expensive, those work best. If you really want to be fancy, or you're doing like a lot of stuff with terminal strips, and not really messing with PC boards, a soldering gun might be a good investment. This is like 25 bucks, and then it's like 10 bucks every 2 other tips, and the tips last not really that long. They last maybe 100 solder joints, but you'll know. Keep the tip screws like tight. Okay, some other things I recommend. Wire strippers, you'll need them, especially for stripping back some of these older wires. And then some pliers to bend and manipulate wires, and then a good set of snips. You gotta get a good set of snips. I got this for about 10 bucks at Micro Center, and they're great. They've lasted a long time. A bunch of companies make these. Try to get the more expensive ones. And then the controversial one, leaded solder. So there's an argument for both sides. Leaded solder is not good for your lungs. So make sure you have proper ventilation if you do choose to use leaded solder, as it's dangerous, especially for your health and your respiratory system. But on the flip side, it works better, it solders better, especially with these old leaded joints. But this is hilarious, but either work outside or get a ventilation fan. This is not an official recommendation. You can get like a proper soldering ventilation system. That's what I'd recommend. But I have this computer fan, which I just run backwards so that it pulls the fumes in. So it's this pretty powerful 12-volt computer fan. And that's what I use. But yeah, I just work outside if you use solder. If you use leaded solder. And I mean, just be careful. Soldering is not the safest thing. It gives you exposure to a lot of odors and noxious chemicals in the air as you are literally melting metal. Alright. So, going into this, hopefully you have some preliminary soldering knowledge. There's so many good videos on YouTube that can help you with that. So first we're going to look at this electrolytic capacitor. So we can pull out of its little cradle here. And I'm going to make our frame a tad looser here. We can read this. 30 microfarads at 150 wall volts, 50 microfarads at 150 wall volts, and black is common negative. Wow, there's only 2 electrolytics in this entire thing. Alright, let's talk a bit more. I'm really going to talk you guys through the basics here. Electrolytic capacitors. So, obviously, your line, your AC, 120 volts, represents a sinusoidal wave. So, it is not at a constant voltage. It is constantly fluctuating, peak to peak, 60 times a second. Unfortunately, that doesn't work well with sensitive electronics like radios, as that difference causes circuits to not work consistently. As you know, the circuits are going to behave wildly differently if they're constantly like snapping between a 20-30 volt difference. So because of that, you have a rectifier tube. So in this case, this should be just like a 35Z5, 35W4. That's the miniature equivalent. So that's going to take your AC signal, and different rectifier tubes work different, but it is going to chop off a component of the signal so it is held at a voltage. I believe it chops off the positive peak. You might want to check that online. But what matters is that it creates a stabler voltage, but it's still not super stable. It still has fluctuations beyond the tolerances of this circuit. So this is where our electrolytic capacitor comes into play, as capacitor is a bank that stores energy, so this will actually store energy and therefore smooth out the waveform. So there's demonstrations, visual demonstrations of this on YouTube, but basically what you need to know is this is a further device to making this a constant, clean, direct current DC signal, which is constantly held at a voltage potential. So that's why this matters, and that's why you hear humming, as you can actually, the hum is the sinusoidal wave of the AC coming through the audio section in the background, right? Excellent. So now we're gonna replace this. Electrolytic capacitors have polarity, which means if you plug them in backwards, they're not going to work, just like diodes or LEDs, light-emitting diodes. These non-polarized capacitors or wax caps, by definition, are not polarized, so you don't need to worry about the order, but for these, you do. So, a few tips that I go with. This is kind of a controversial subject. You can go over on these values, both in voltage and capacitance. Don't go under on either. Never go under on voltage. And, you know, plus or minus like 5% or minus 5% under is probably fine, but there's common values. But going over, that's fine, especially if you're going over like 5 or 10%. So like a 30 microfarad cap, you can only find those on like the tube amp enthusiast sites, and they're like $5 a cap. Or you can get a 33 microfarad cap for like 50 cents if you buy them in bulk. 30 microfarads, 150 wall volts. Here we go. So microfarad is our capacitance value, and our volts are the it fluctuates, but this is going to be the average operating voltage. Maximum operating voltage still shouldn't exceed this by much. A lot of caps had like a operating and a maximum rating, but take what's on here as a maximum. Never throw this in a circuit that at spikes goes above 250 volts, because obviously this circuit may run at 130, 140 volts, but it's going to spike to like 210 when you turn on the power switch. If you don't, this is why it's great for old electronics to have a variac, especially with old components, because if you put in a 120 rated cap, might work after the spikes settle down, but it will blow open if on enough power-up cycles. So here you go. 250 volts, 33 microfarads. And let's check this. 30 microfarads, 150 volts. Great. Then green is 50 microfarads, 150 volts. So this is where our 3% under rule comes into play. I have a 47 microfarad, 250 volt capacitor. Remember, over on voltage is fine. And under on capacitance, you want to be real careful. This is 47 microfarads. This is around 5% under, which is fine. If you're putting in like a 33, your circuit's going to have a bit of backing hum and other adverse effects. But 47 microfarads, 250 volts, totally works for a 50. Now, black, common negative. So the way these capacitors work is the positives are separate, but the negatives are tied together. So we have our positives, our negatives, and our negatives are actually going to be tied together like so. All right. So now we're going to snip out the old cap. This is what I do. I always keep the cap handy. If you go back to my Northern Electric video, I think it was part 1, the cap I had wasn't marked. Sometimes these won't be marked, so they always have a part number, unless if something bad has happened and the outer casing is completely gone. Part number, then if you can't find that, schematics. Cannot push schematics enough. So useful. They can tell you everything about the circuit. Get some model numbers, and if not, places like Radio Museum can help you find your model based on pictures or descriptions or tube counts, whatever. But if we have all this information, we can cut the old cap out, like so. Keep the cap present for a reference. And here we go. I usually stick these straight up So I know where they are. 1, 2, 3. Excellent. So again, our red is the positive, so the non-tied together section of our 33, was 30 now, 33 microfarad electrolytic polar capacitor. And the green is the positive of our 47 microfarad polar electrolytic capacitor. And then our black is going to share the common negative of both, right? So that's important. Remember, you cannot tie both positives together, even though if you go back to my like GD52 video, in that case, yes, you can tie the positives together. But in general cases, you don't want to do that unless the circuit specifically calls for it. Okay. So we can take a look. We can tell this is a hot chassis right away. We have a grounding cap coming off the neutral part of our AC line. AC is not positive and negative. There is a hot and neutral where the wave is supplied and where it returns. So our negative is actually going to our neutral here. And then these are going to various parts. This is going to a tube pin. They're both going to tube pins. So this is going to come with time and experience. But you want to put these in a way that makes sense. So for example, we have our green, our 50. So we could put it in like this, right? And then stuff it back in there. But A, if you don't really adequately insulate that, that's going to be a hazard for shorts. And B, in rare cases, longer lead length will result in detuning circuits, extra resistance, because remember, the reason why AC is used at all is because it carries great across great distances. DC does not. So this is more in like tuned audio circuits, especially FM. But yeah, try to keep lead length to a minimum. It can also be an antenna for interference. So if you keep something long, especially next to, you know, the line cord, which still has that dirty AC that we're trying to get rid of, you can pick up noise. So this is what I'm actually going to do. I'm going to cut this down here. I am going to take our negative, like such, and I am going to run it to these capacitors so the positives are actually touching or soldered directly to the joint. So let's do that. Our negative is going to stay the same length, so we are going to strip this. Sometimes wire gauge will be disclosed but on a schematic, but usually it's not. Of course, this is our arch nemesis. No, it's just our enemy. Aluminum wire. I hate aluminum wire because it's stupid and my house is made of it, and there's so many horrible wiring faults. But no worries. Oh, and another thing, again, sometimes the colors on these wires will fade, and in that case, you want to reference the schematic. You're like, okay, there's a big, I don't know, I'm sure you can read this, I'm going to say, you know, 5,500 ohm resistor going to it. And on this one, it goes straight to the tube pin. And then you look at that in real life. Okay, this one's going to the tube pin. This one's going from the big resistor. Okay, well, on the schematic it says the big resistor goes to the 50 and the direct tube pin goes to 30. And you can work backwards like that. So that's great. So we have our soldering gun. In this case, we're actually going to completely remove this. Remember, green is 50 microfarads, the positive of 50 microfarads. So, snip this. Here we don't need the wire. We're going to stretch these leads out. Another thing that's going to take time is, do you add insulation or not? In this case, I'm not going to. I don't need to. There is nothing in the immediate vicinity of this capacitor that is going to short to it. But in some cases you will. Okay, let's talk about soldering lead types. Well, the types. Let's talk about the different types of soldering joints. So some people imagine these are bare wires. Some people just lay the wires on top of each other like this. Well, that's a poor decision because Well, if the solder fails, wires come apart. So this is what I recommend, a J-hook method. So we are going to loop the wire and loop the wire, and then we can hook them, and then I sometimes crimp them later on, and then we solder them. But even if the solder fails, so imagine solder fails, well, obviously they're not going to be held together great, but you can hold them together. So that's what I commonly use, is a J-hook method, or a simple loop. So on our capacitor, we have negative marked, and we can obviously, through process of elimination, assume that the side without the negative is the positive. So we're going to cut a little bit off. Again, trial and error. Get an All-American 5. Don't get a crazy, like, 20-tube radio to start on this. Because All-American 5s are simple and easy to work on, except the ones that have silver mica disease. So you can see that still didn't quite hold in. So we are going to attempt to make a J-hook on this side too. And great, because now our capacitor holds in. So now that it is mechanically holding, if it will not hold by itself, you know you need to make a better mechanical connection. So now we're going to heat up our soldering gun, and we're going to send this through our ISO transformer. We don't want to send this through our isolation transformer. That's going to freaking melt the guts out of it. All right. Now, got our soldering gun. Got our solder. Our lead did slip out, so we're going to make that a tad tighter so that doesn't slip out. And then, remember, apply solder to the joint, not the soldering gun. Same goes with the soldering iron. So that you will make a cold soldering joint if you're just dumping solder on cold metal. So wait for the soldering gun to heat up. Same with the soldering iron. From last time, unless it's a brand new device, you will see it's not smoke. It is the flux burning off of the iron or gun. And remember, apply it. So the joint might go back here and revise my work a bit. Really give it a nice, adequate amount of time to heat up. You should not, all the leads should be absorbed in the solder. You should not be able to see one lead overlaid upon the other. We've not used enough solder. And the last thing is a pull test. You can pull the joint apart. You have not put enough solder on. Okay, great. Again, the green, which we cut off, is the positive over 50. Now the red, which is a little bit faded, but you can still make out it's red, is the positive over 30. So now let's stick our 30 in. And here's another thing. So we have this wire here and the resistor here. Since there is no passive, capacitive, or any other sort of component between these two, we can hook the capacitor up to the resistor as it is just a wire. It has not gone through the element yet, so it is essentially still making a resistance-free path, or near so, to our joint we originally intended. So I'm actually going to solder this to the outgoing side of the resistor, because we have our other component, resistor, outgoing to our joint, which we soldered to in the first place. So again, we're going to make our hook here. Oop. Throw loose leads away. We're going to bend it in the shape. We're actually going to really crimp it in so that it kind of locks on there. Our positive side, remember. Always got to keep track. Make sure excess wires don't scrape your coils. And another thing, you can sometimes attach a loose alligator clip to the thing you're soldering to as a heat sink, because if you overheat some components, they will internally fall apart. Remember, you are melting stuff to solder, but you might melt stuff you didn't intentionally want to. Let me just pull these wires away a bit. both sides. And sometimes if your soldering joint is really dirty, it might not be a bad idea to use some sandpaper on it as you can clean it. But this one, we did break through the coating. That's another nice thing with a soldering gun. It's a much higher powered device, so that you can really break through coatings. Okay, we are going to tuck our capacitor down here, and now these will come together like so. Let me quickly bend this down. And you might want to also put a ruler or a straight edge on top to make sure that when you put it back in its cabinet, the tubes are, or sorry, the capacitors, resistors, whatever, your replacement components are not going to be smushed. You put them in. I had that issue with radio I worked on a long time ago. Okay. So, remember, negative to negative, always double check, always double check. We are going to wire these together. Again, using J-hooks. Always want a mechanical component of your connection. So we're going to flip off our excess, which went somewhere. There it went. This is where our tweezers are helpful for. This is optional, but I find a set of tweezers incredibly useful. Come on. There we go. Okay. We J-hook these together. Now, one more thing we're going to do. I usually tin wires, which means, well, first I'm going to bend them into shape in the way we want. Again, another J-hook. But before I solder it to the other devices, I'm going to apply some solder before. So tinning, though, tinning is great for stranded wires or dirty solid wires even, just so that it really just nicely flows. So you want to get your soldering gun or iron nice and hot so that it does stick. And then, nice and hot, look at that. I'm going to apply it to the wire, heat it up, give it some time to really heat that wire up. Then you're going to apply solder to the wire, like so. That's fine. Okay, wire's going to be hot, hot, hot after this, but we go ahead. This is where our pliers are useful because this thing is hot. We're going to go ahead and attach it to all three of these caps that we just put in. Now we're going to solder them. Soldering guns, they're high powered, so you might want to give them a break every couple minutes. I did not, and these things only last so long. We're good. So now we've tinned this wire, it flows very easily and quite easily solders to everything else we're soldering here. And there you go. Now, we're not really in danger of touching anything else, but if we were, we would want to put in some heat shrink, which I recommend get a heat gun for that. Not a soldering iron like I've been using. But there you go. All three of these capacitors have been replaced. You can take a close look here. And you can see we have our 50, our 30, the positives going to each, and the negative trailing off. Now, something I cannot stress enough. Test after every capacitor or every couple of capacitors you replace, because if you replace every capacitor and the radio doesn't work, you will be overwhelmed. You won't know where to start because you don't know where you will have messed up. If you check every couple caps, you'll be like, okay, I just need to check these couple connections, check them with the schematic, check them with some pictures, take reference pictures before. Another thing, if you do not have an isolation transformer, which I recommend getting, all American 5 radios are hot chassis radios, which means the chassis is capacitively coupled to the neutral side of the line cord. When in doubt, only touch it with the knobs, but really just get an isolation transformer. We're gonna plug this in and turn it on. You just want to make sure this still works, right? So it's on, radio's on. We're gonna bring them up to about 60 volts. You should see a couple tubes starting to glow. Obviously, if you smell something, hear something, or anything, turn it off, reassess your work. I think we're in business here. 90 volts. All of our tubes are heating up now. It's good. These are series strung devices, which means that if one thing's out, a lot of the tubes will not light up. And this works.
Pushing a bull by any means, but it is one of the cheaper EVs out there. Literally, if you buy the right mold around the 30K range, that... For sure. The team line drive grabbed by Pablo as he jumped up and took a...
And this is working great. No backing hum.
This time of year in spring training, crosstown.
Speaker's rubbing a tad, but that's all right. Okay. Great. Another thing that's great to invest is in an infrared heat gun or thermometer. You know, one of those things you use that a lot of people use to check people's heads. That's contactless in the pandemic. Get one of those, check your components. Another thing, special electrolyte capacitors, they will have a charge. I highly recommend you get a bleeder resistor, something. This is a 2.7 thousand ohm, that's what the K means, resistor, 7 watts. And you're just going to put that across your capacitors to discharge them, as they, like batteries, but much higher voltage, will still have a remaining charge in them. And you saw a little bit of a spark there, so you know. And now they're good to touch. Alright, I'm going to walk you through replacing one of these wax caps, and I'm going to do the rest. The same method applies to all of them, except sometimes getting to difficult ones. The only time I've ever had to remove a component to replace a wax capacitor was in the 38116, which I'm still working on. Actually shot some footage for that, but I need to edit it. Usually, you know, bend some components around, you can get it out. Now, we are going to go macro here. We are going to replace, what should we replace here? Let's replace this one. This is a nice one, nice and easy. And this is a good example. Wax caps are sometimes very obscured. So, this thing needs to be replaced. The problem is we can't read it. So, I'd look at the schematic, but also if you need to, you can actually get your soldering gun or soldering iron. And again, ventilation. You can read what's on. I see it's rated for 600 volts. Haven't quite gotten the rest, so take some pictures. Then what you're gonna do is you're gonna pull one side of the cap out through from the line. So we're going to snip it and raise it up. Now we can see it very easily. This cap reads, well, I just obscured it with my finger, but let me get it so you guys can read it. 0.1 microfarads at 600 wall volts. Again, be gentle with the soldering iron, especially soldering gun. So, 0.01 microfarads to 600 volts. These are non-polarized. Don't try to look for these capacitors in an electrolytic value. So, capacitors actually have like keys or codes. A 0.01 is a 103. So there are charts online, just like resistors, where you can look it up. Again, voltage matters, and for this, you don't want to go over. You want to stay within 5 or 10%. So this is a exact, actually, 0.01 at 630 volts. You can see this thing's tiny in comparison to the original, which is fine. Check decimals. These are sometimes tricky. 0.01 microfarads, you can check on this chart too. 103 is 103, 0.01. Great. So we have our old leads here, 1, 2. So we're gonna snip the old cap out. Remember where the old leads are, and don't go around snipping every cap out and then start replacing them. Do it one at a time, because if you go away, you'll forget. So in this case, I'm actually gonna opt to put it in like this. Sometimes you want to put them in line like this. Obviously, J-hook both sides. Okay. So we're gonna turn this around and J-hook this side too. Usually want them in opposite directions so the cap can't fall out. Great. Remember, these non-polar, you can put them in either any way. Then we're gonna bend them like this so that our cap, the leads are going 2 different ways. And since I know this is gonna be long, I'm gonna cut off the lead excess. You don't want to cut off lead excess unless you know that you have it right, because remember, you can always get rid of lead, but it's always harder to add lead. So now you can stick that in. Great. You can see this is all in. We might want to use our crimpers to just crimp this in further to really make sure there's a good connection. And there you go. It should be able to pretty well hold itself without being soldered. So, once again, same method. If your leads are really dirty, you might want to put some sandpaper, 122, 20 grit, whatever, and clean them up. But right now, I think we're good. So we got our soldering gun and our solder. And again, wait for it to heat up, and then to our joint, heat up our joint. And apply some solder, like such. This old lead has some wax on it, so it's getting a bit stubborn. What? Ooh, we do not got it. As an example, the wax actually stopped this lead from making contact. So I'm actually going to opt to bridge this with something a bit further down. I'm going to tell you what I'm doing after I'm done here. Okay, so here's what I did. Coming up, we have the J-hook lead, and then it's going to a bed of other leads. The J-hook lead, unfortunately, had some wax. It was dirty. Before I decided to pull the whole cap out, I was like, okay, I can try to solder to this other lead. And it worked. So, exhaust your options before pulling your caps out. Because in addition to wasting your time, using up your time, if you pull your stuff out, put it in again over and over, experience lead fatigue. If you bend a piece of metal back and forth a bunch, it's going to snap. So, I just checked that and it worked. So, great. Now, we are going to solder the other side in. So, let me heat them both up. And it flowed. We can do a pull test, but it worked. I actually heard stuff coming out of the speaker there, so I think we might, especially with miniature tubes, pull your tubes out when working on your radio, because you might damage them if you heat them up too much. Luckily, I don't think I heated up this tube too much. But there you go. And here is our replaced capacitor. We should be able to, do a pull test, and it's nice and good. So, there you go. Nice and soldered in. We have 1 and 2. So, can you guys remember what we need to do after we replace each component or every couple components? Yeah, we need to turn the radio on. So before we do that, I'm actually going to if you can afford it, try to put some compressed air through the radio. Get rid of all the dust, especially on the other side, as you can also get rid of some leaves. Don't blow. You can be with the condenser, but be really careful with the speaker. There's a big dust boy in here. Oh! Freaking thing came off. But yeah, try to dust off the underside so that there's any loose leads are gone. Another thing, well, I'll show you that after. So remember, let's test again. So look underside, make sure nothing's in our way here. Nope. So this should work, right? As all we did is we replaced a component with a component of equal value and function, or close enough. So have our radio turned on, this turned on, bring our variac up to 60 volts. Couple tube filaments should be going. Let's straighten these tubes out a bit. A couple are going. Let's pull this up to 90. All the filaments are going. Good sign, especially if you didn't complete a connection. The whole filament string may not light up, but since they're all lighting up, it's a good sign. And here comes our radio. Bring this up. Never mind, it wasn't on KOA. This is plenty loud.
Those groups have the...
Although, audio output is running a little bit less bright, and the other stations aren't very good, but this is also an All-American 5, so, Not a bad idea to also test tubes, but remember, most issues with the radio are caused by capacitors, resistors, passives, not tubes. Alright, I'm going to replace the remainder of these capacitors as I showed you the method. So it's the same thing for all these others. We'll come back to do one more test. Alright, I replaced 1, 2, 3, 4, 5, and then 2 electrolytics. Replaced all the capacitors. Alright, Before we turn this on, I'm going to put some deoxit in the volume controls, some contact cleaner. Some people say WD-40 works as well. Haven't tried that yet. So, a couple things. Well, one main thing. This is flammable. This is very flammable. And I actually, from the Colorado Radio Collectors newsletter, I read a story of where someone just sprayed a ton of cleaner in a control and just turned the radio on immediately, and it just completely caught on fire. And it was like it was a Zenith Walton. So yeah, not a great radio to burn down. He's now looking to rebuild a ton of it. So yeah, might want to wait a little bit after putting your contact cleaner in. That's good enough. Just work the control back a bit. This control's pretty clean already. Another thing we're going to do, well, two more things. First of all, we're going to lubricate our dial string assembly. We're just going to get this oil. It's nice if you have I know a guy on YouTube uses Zoom Spout branded oil. Apparently that works real well. So you can see this is a little bit tight. A bit tight, bro. We're gonna pull our plates back. There we go. There we go. Try not to drop any in the plates. Here's the big one. Again, try to not drop oil on the plates. And then last one probably want to do is in here. Yeah, it's just right here. Don't want to get it on the dial string because it'll slip. But now, let's see. Oh, the radio tune's much nicer now. Lots of resistance removed. The tuning Mac. And then another thing is I noticed the pilot bulb was out right here. This will illuminate the dial. And in some All-American 5 circuits, the whole radio actually won't work because the pilot bulb is out. And this is it doesn't really matter, it's a 44. So we can check with our multimeter to see if it's the circuit or the bulb. I hope it's the bulb. Fixing the circuit's always worse. And our bulb is open. I don't even remember where I put my bulbs. Okay. Got a new bulb here. I got this in like a 10-pack from Amazon. It was for like paintball people. These are expensive. These are like $1 a bulb, and I'm like, come on, man. If I burn one out, is that $1? So we can check our new bulb. Wow, it works. So great. I'm gonna take our new bulb here. I gotta throw these leads away. Gonna take our new bulb here and put it in the socket. These you push in and turn. There we go, it's in. Okay, that's in. Let's not forget to put our tubes back in. Might want to clean the sockets. I don't have enough deoxit to do so, but it's always a good idea. Put some contact cleaner in the sockets. Okay, great. Now, let's plug her in. Oh, one more thing. I did put a new plug end on this. It's gonna just be a little bit safer. I decided to not replace the line cord. I might eventually. I'd err on the side of replacing it if you're in doubt. So 60 volts. Should see some filaments. You can see how our pilot bulb is glowing. Glowing dimly as our tubes heat up. Okay, we're gonna bring her up to 90 volts. Is a good sign.
Raleigh House can help. Call 720-797-8717.
Let's stay away.
Nodding yes.
That's KOA.
And whether he was okay from the Rockies dugout, he says he's
Very
good.
good.
Their salary-based mortgage consultants will...
All right, let's put this back in the cabinet. All right, the radio's all put back together. Put a nice coat of gloss on the top. Oof, still a bit slick. I think it looks very nice. So, we're gonna just plug it into straight all line. Nice. We got a bit of a nice glow from the dial light.
And capitalistlaw.com.
This is Mike Rosen. Let me tell you about my friends at Two mortgage payments. American Financing, 303-69. That's 303-6957. AmericanFinancing.net.
NMLS 182334. NMLSConsumerAccess.org.
Yeah, it works. Works great too. Oop. There you go. All done. Hope you learned a little bit. Thanks for watching. Bye.